Hello and welcome back to the lab. Finishing up the 475A, we have to do the DM44, so hopefully, given how much of a problem this scope has been, this is going on about a month being on the bench. This will be the last installment in this video series. I'm hoping we can crank through the DMM, get through the time base, and then this guy will actually be done. Be able to tuck him back in the box and get it back to its owner. I'm waiting on the gear to warm up in the lab, and one of the things was I was looking through the calibration manual because I haven't done a DM44 yet. For those that are considering on grabbing a scope with a piggybacked meter, this doesn't do AC. So there's no AC volts, AC circuitry, anything that you'd find in a normal DMM on the DM. I'm guessing they expect you to do that with the scope portion of it. It's just temperature, volts and ohms now, and the delay time divisions. The other thing with the DM44 is I won't be able to calibrate the temperature probe because I can test it. However, the alignment step for the probe aligns it to the probe. And for what the owner told me, the probe that came with it is not going back with it. So I will, there will be one step that the owner of the scope has to do when they get it back, and that's just align the probe. You just put it in ice water and dial to 32. It's not that big a deal. But I'm waiting on the 7510 to warm up. I've got the Fluke 343 on, and I've got the TGs on that we're going to need. Resistance standard-wise for this one, I've got a resistor box to handle the low end, but I did find some 1% metal foam resistors for the high end. And we'll go from there. I do not have a resistance standard in the lab quite yet. That'll go all the way up to mega ohms, but we can put a bunch of resistors on it and just make sure it's giving us good readings from a sanity standpoint after we do the alignment. So I'm going to let everything finish warming up, and then we will get into some alignments. Okay, I got the notification from the 7510 that the warm-up time was done. So now what we're going to do is we're going to tweak the reference current. I need 4.71, so we're a little low. Well, I can't ask for better than that. Next up is the 2 volt. Well, I like the fact that my Fluke's cooperating today. So we got 1.800. Just for grins, let's see how well. This is only 1.8 volts, so it's not a hazard yet. Let's see how well the 6500 is. Not going to argue with that. Also, it should be noted that when you are up here working around the boards and things like that, especially when you're testing the higher voltage range, because this all goes up to 1.2 kilovolts, there will be hazardous voltages on this board and all over this scope. So definitely take care. And we actually need to kick this down to 2 volts to get better resolution. And I'm supposed to adjust for 1.800, and we are good there. Now it wants me to reverse the polarity. And that is good as well. So actually that step doesn't need anything. Perfect. So we'll stand by the voltage reference. And we will check this now with a shorting bar. Perfect. This is actually not a bridge connector. It's a short bar in banana plug form. Pretty useful for calibrations. Nice low impedance. All right, I need 180 millivolts out of the calibrator. Down, make bigger. So we will turn this back on. That should be, we need a little bit more. So we'll there we go. That's going to average out to 180 millivolts. So we're good there. Plug this in here. And 200. We are at 180.0. And that is what we should be. So no adjustment is necessary there. Apparently we start by sending it into orbit. 1.2000 kV. Now this just got spicy. No, that's 100. That's only 120 volts, so that's actually reading right. So 10 to 0. Actually, my calibrator will only go to 1.1. It won't go to 1.2. So we'll have to top out at 1.1, but it's pretty much dial a voltage. So now I don't want to touch anything because even though that says 1.1, we're on the 1.2 kV range. So that's 1.1 kV into those input connectors. 180 volts. I'll back this back down to 180. Yep, that's fine. 200 volts should show us 180, so we'll check the range. 177.9 within spec. So we'll go down to 18 volts. And that is good. In the 20 volt range. That is also within spec. So we will now check 1.8 volts. That is good. 2 volts. These are going to be fine because we just calibrated those. Yeah. So that is, voltage-wise, that one's bang on. We don't need to adjust anything, which is fantastic. Very nice. The DC standard was bang on today. Okay, so starting up, we'll check our 18K resistance range. These are 1% resistors left over from the chip tester project. Earlier in the video series, I did clean pretty much all the chips by testing them all independently. So let's see. We do need to adjust our 3047. So our 3047 is this pot that you get into from the side. So we will get an adjustment tool of appropriate type. There we go. Well, I don't have 1.2 or 1.8Ks, but I do have 1.9s. Actually, they're 2K 1%, but they read 199 on the 7510. So I'm looking for 3007. And the low ohms range is over here by the switch. So we dial this back to 199. Helps if I put it in the right range. Actually, I have an extra digit, so I can make this completely match the 7510. So we'll just pop this up here. We're on 992. So we'll align this to the 7510. There we go. Okay, we have a decade resistance box set to 180 ohms, but we're off by 0.2. I need to compromise this for both ranges, so we'll back this off to 0.1. That'll make the other one read 0.1 high, or 0.1 low and 0.1 high, and that'd be the best compromise. Cool. Okay, that's it for the DMM section. So next is the timing section for the scope, and we will need time marks for that. So in the DMM 44 manual, make sure you're using the correct section of the manual, because there's a alignment procedure for a 465 and 465B, and then there's alignment procedure for a 475 and 475A. And the adjustment points are different. Perfect example is here. This side is for the 465. This side is for the 475. So, very important. Okay, we're set up to do the horizontal alignment and our intensified zone. As you can see, we can move it. It's right here. However, it needs to be up in here. So, with this fully counterclockwise, we have to move that up. So, we need to adjust our 938. And just to make the alignment fun, the two potentiometers we need to adjust are right here at the bottom. 938 and 936. So 938 is start, 936 is stop. Keep an eye on the intensified section. We want that to be in the middle of the time mark, so right there. Now what we have to do is roll this completely the opposite way. And That is where it needs to go, but I need to extend the sweep out just a little bit. Right there, I kind of have to do it in the dark because it's so fast. So see, this is actually wrong because this is coming down. So it should be, yeah, there's the time mark right there. It's 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's actually way off. Okay, I need to move that. Nope, that'll be the last one. So, yeah, the sweep length was is a little long on this one. Okay, just checking the B ends A, delay time positions in mid-range. We can move it around, but the sweep ends at the intensified portion, which is the appropriate response. Well, a lot of these adjustments are on the bottom of the board, but going from here to here, we can see our horizontal gain is off. Needs a bit of adjustment. So we need to adjust 1155, which is on the bottom of the board as well. It's actually right here. Pull some of the speed out. There we go. Okay, that's looking better. I'm going to zoom in with the camera. I'm actually going to cheat and use the camera as a magnifier. But down here's my reference. My point of interest is up here. Make sure I don't grab the wrong potentiometer because we are getting very close to having this complete. And right there. But now I'm going to move it and readjust because I'll have to do this a few times. Pull some of the gain out. Back it down. Too much. Right about there. Nah, still a little off. A little much. There we go. Right about there. That's what I'm looking for. And I'm looking for the tops of the time marks. The intensified looks pretty good, but I want to adjust it a little bit. So R950. All right, sweep length of 10.5 to 12.5 divisions, so that's 1 to 10 divisions. $11, 12.5, so right, barely spec, but we are in spec. Okay, we're checking the magnifier now. Actually, it's pretty close. We need to adjust 1130. And we have to do this a few times because there's interactions. So we pull the, so we're on the second time mark. And we disable the 10x mag. And then we bring the second time mark back to the center. Like so. Do it again. The movement is a little bit of thermal effect in the transistors. You're seeing thermal settling. So this is also one of the reasons why I need to make that calibration card for the 7854, because it's the thermal channel balance. That's why I'm giving it a second, because it'll come back. Okay, there we go. All right, so we check the variable. Zoom out for this. Check variable. And 10 millisecond time marks. Bounce this up to 10. Pull this back. Less than 4 divisions. That passes. A intensified 0.2. B time, 1 mic. B trigger source starts after delay. Yes. And it wants 0.1. Alright, so that's 1, 2, 3. So we go to time and oh wait, 1 over time. We superimpose the time marks. So it's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19. There's the 19th time marker. Okay. So now we want delay time. Now this would superimpose the time marks. And I was on the wrong setting. This should be 1.6, so I need to adjust this just a little bit because we're at 1597. That one's confusing as to what they want you to do. So you're setting it up so it's on the 3rd time mark. Then you count to the 19th time mark, hit B delay, superimpose them, and then this should be 1.6. But I need to adjust 3287. Okay, so that is right here. So 3287 is this adjustment right here. Now we're going to hit 1 overtime. They are still superimposed, and this should be 6.25, which it is. So we do not need to adjust 3033. So now it wants A intensified and time. So now we want be delayed, and it should be exactly 1. Okay, so the time bases are synced up. Sweet. And if I hit 1 overtime, this needs to be slightly adjusted because this should be C3162 for 10.0. Let's see if this one has it. This one actually has R3162. It's this potentiometer right here. So we'll dial this for 1.0. Didn't take much. Everything in between is just checks, so I will check them out real quick and then I'll be back. Checking the 20 microsecond timing, everything looks good there, so C1064 and 1023 do not need to be adjusted. So now we need to check the 0.2 microsecond timing, speed way up. 1 microsecond, so we're going to do double time marks again. Maybe? No? 0.1. Oops. And we're starting to get a little quick. And my high speed, that could be adjusted a little bit. So we want to adjust C109 and C125. Actually, in this scope, it's C125. And I get to that through the top of the DMM. Since we got to go through the board, we'll grab a non-conductive tool. And it is the second capacitor, way down here. And that looks pretty good. I needed a flashlight to see down in there. It's pretty far down in that board. Okay, we do need to adjust C025. Ooh, this one's way off. That's looking better. Yeah, that looks good. Third time mark. Hey, intensified, where are you? Turn this down. Third time mark is in the center. Okay, now what I have to do is I have to get this capacitor lined up again. I'll just go back in here, same cap. But what I need to do is I need to, hang on a second. That's not doing what I'm expecting it to do. What did I grabbed the wrong capacitor, I think. What does it want you to do? Because it's moving both. Yeah, it will work. I just have to have confidence in the calibration document. So what will happen is we will take this capacitor again. Come on, get back on there. And we'll tweak this, and they will come closer together. And they will... Ooh, God, it's touchy. Superimpose just like that. Yeah, let's dial it in a little bit better. So we'll put that one to the center. Just a bit more. Not going to take much. Went a touch too far and I slipped off. So now I got to find it again. Getting real close. That's about as good as I'm going to get it. Any more tweaking and it's going to fly off. Okay, with 5 nanosecond time marks, I just found out a problem with my TG501, so now I got to fix it. So I'm using the other TG501 I have in a lab. We're within tolerance for the 5 nanosecond. We'll check the 2 nanosecond. And this one doesn't want to output time mark. They're lower amplitude. Let's see. I had it. Let's give it a little more amplitude to trigger off of. Yeah, 2 nanosecond looks good as well. Just barely making the 0.2 because we're at 0.2 divisions, which is right on spec. Okay, I do not have to go through the X and Y and XY modes on this particular scope because we've just done a full alignment on the vertical. So we know the vertical's good from the alignment before. And that will actually conclude the alignment on this particular 475. So I can honestly say finally this scope is complete. This has been a project. This has been a real huge restoration. Lots of effort went into this scope. It's had about a month and a half of bench time to get it to this point. So this was not a small undertaking, but we have reached the end and we are good to go. Now I have to figure out why the highest speed on my TG501 isn't working, but that's for another day. So thanks for stopping by and checking out the channel, and I will see everybody in the next video. As always, more is on the way, and I will see everyone in the comments section. One last thing, since everybody hung through these videos for this long, and especially if anybody's just seeing this video, here is the scope, finally back in the case, ready to go back to the owner, and complete. For those that are finding this video for the first time, this is the culmination of a series of videos to get this scope up and running. This is the dish of shame for this particular project. These are all the bad parts from this scope. There's quite a few of them in here. So a link will be in the description. Well, there's a playlist for this particular series of videos, and there's this series of troubleshooting videos is also on the Tech Wiki. So check them out if you're curious as to how this many parts went bad in this particular scope. I will see everybody in the next video. Bye for now.